Starting a new chapter, and this is section 4.1, linear functions and their properties, and you can get a glimpse there of the objectives that we want to try to accomplish with this lesson. Hopefully you'll have understanding of all of these four different objectives, and then with practice you will develop some mastery regarding those, so you'll be ready for this part of your test. So let's just get right into some homework examples. You probably should go ahead and open your book to page 278 so that you can get a glimpse, get an idea of the instructions, the directions that the book is going to ask you for these certain types of problems. So I'm doing an example. As you can see there, I've chosen number 13 for the block of problems from 13 to 20. They all pretty much work the same way, same directions. Four-part answer. So given this particular function, can we identify the slope? That's what m stands for, and m, of course, if this is in slope-intercept form, which it is, m is the number in front, the coefficient of x, the number in front of x, which is 2. The b stands for y-intercept, and that's the constant, which we say is, we identify as 3. Sketching the graph, pretty simple. This is a review. We start at 3 on the y-axis. We count a slope of 2, positive, and get our straight edge and connect those dots. And there we have the graph of the function f of x equals 2x plus 3. Takes care of the graph. The average rate of change, well, that's really another way of describing the slope. Slope, we would say, is a constant rate of change for a line. The average rate of change, in this case, rate of change is the slope of 2. And is this function increasing, decreasing, or constant? Well, for linear functions that have a positive slope, like this one, we say that they are increasing. Negative slope linear functions would be decreasing, and then a horizontal line would be considered constant. Like this one. This isn't one of your exact homework problems, but it's very similar. F of x equals 5. Well, this has a slope of 0. It has a y-intercept of 5. The graph of this is just a horizontal line that crosses the y-axis at 5. So if you were looking at this in terms of slope-intercept form, it would be 0x, which is 0, plus 5. So we say it has a slope of 0. Average rate of change, another way of describing the slope, would be 0. And this is again an example of a constant function when it's a horizontal line. Okay, in the next block of problems, you're given an XY table of values, and you're to determine whether or not this table represents a function that is linear or nonlinear. Well, if it's linear, then it has a constant rate of change. So to test whether or not this table represents a linear function, we're just going to use the slope formula that we learned way back in Algebra 1. And we're just going to group these up into ordered pairs. And let's just say, for example, these first two ordered pairs, I'll just put a brace around these ordered pairs, and we'll see what the slope would be for these. So y2, we'll just say y2 is 1 minus y1 is 4 over -1 minus -2. And when we find the slope represented by these two ordered pairs, we're going to get -3. Okay? And if this is a linear function, then every time we do this slope formula on ordered pairs, then we should get the same result for the slope. Alright, so let's just drop down, and now I'm going to come over here and find the slope using these ordered pairs. Okay, so this time y2 minus y1 over x2 minus x1, and that's going to be also negative 3. Alright, so far so good. And we'll just slide down by 1, and we'll do that for this next set of ordered pairs. I'll just come down here and do it in green. So y2 minus y1 over x2 minus x1. Negative 5 plus 2 is negative 3. Alright, so far so good. And then finally, let's do this last set of ordered pairs. And y2 minus y1 over x2 minus x1. And we got the same result every time. So we are going to label this as a linear function. And the slope, since it is linear, determine the slope. We found out that that's negative 3. So this is the same kind of process that you're going to go through on the problems that are remaining that you have to do 22 through 24. Actually, 22 through 28. It continues on to the next page. Alright, so see if there is a constant rate of change indicated by the slope formula for all of the different pairs, ordered pairs in your table. Okay, now we move to a different type of problem, and this is taken straight out of your book on page 279. This is number 29, as you can see. Given two functions, they want us to come up with some different pieces of information. Letter A says solve f of x equals 0. Okay, well, what they're saying here really is f of x is 4x minus 1. So what would 4x minus 1 equals 0 be? So we just solve this like we're used to doing, and my answer here would be x is 1/4. Okay, so in other words, another way of looking at it is if you input 1/4 in for x, do you get 0 for y, or f of x? So that's another way you can kind of check yourself to make sure it's right. What about this? Solve f of x is greater than 0. Well, that should be pretty easy. If it's equal to 0 at x is 1/4, then it should be x is greater than 1/4 will be greater than 0. So in other words, you're basically solving this inequality. And so that's your answer for part B. Solve f of x equals g of x. So that means what do we get for x if we let these two functions equal each other? So let the two functions equal each other, solve for x, and you add 2x to both sides, you get 6x. Add 1 to both sides, you get 6. So we get x is 1. Alright. Part D, let's solve f of x is less than g of x. So setting these up in inequality form. Okay. We get x is less than or equal to 1. And then on the next slide, we're going to graph these two functions and label the point that represents the solution. The solution is the point of intersection. If these two do cross, then the solution for x and y will be the ordered pair that represents the point of intersection. So let's see where these two cross. So let's do f of x equals 4x minus 1. So we start at negative 1 y-intercept, and we count a slope of 4. And we'll draw that line. And then in blue, let's do the other line, negative 2x plus 5. Y-intercept 5, slope negative 2. You can already see where the point of intersection is going to be. Alright, so the solution, where f of x equals g of x, that is this ordered pair 1 3. All right, and that is the answer to part E. We graph the two functions and we label the point that represents the solution. All right, and that is all we're asked to do on problems like number 29. Okay, 31 is a little different. They give you this graph, and I just reproduced it. And we got parts A through F to parts A through F that we need to answer. So given this function y equals f of x, and we see some ordered pair, some points that lie on the function on the line, what does this mean when we solve f of x equals 50? Well, another way of thinking of f of x is thinking of y. So what ordered pair has a y coordinate of 50, in other words? And so my answer for letter A is going to be 40. Okay, pretty easy. Letter B, let's solve f of x equals 80, or y is equal to 80 when x is 88. All right. Part C, solve f of x equals 0. Y is 0 when x is negative 40. Okay, letter D. What about f of x is greater than 50? Okay, well here's where f of x is 50. Well, f of x is greater than 50 when x is greater than 40. Okay, pretty easy. F of x is less than or equal to 80 when x is less than or equal to 88. And then finally, when f of x or y is between 0 and 80, all right, when x is between negative 40 and positive 88. I guess I probably should write this using our fancy notation. X such that negative 40 less than, just less than, x less than 88. Okay, and those are your answers for A through F. Not too bad. Given the y, you're basically coming up with the related x values. Okay, number 33, wanted to give you a sample of this so that you can answer problems like it. We're given these two functions, y equals f of x in blue and y equals g of x in red. We see where they cross. And this says to solve f of x equals g of x. Hopefully you can see they both cross, obviously, at negative 4, 6. In other words, the two y coordinates are the same here, which are both 6. Well, what x coordinate causes them to be the same at 6? So in other words, what we're looking for here when we're solving, we're looking for x. And the solution here is x is negative 4. Okay, they both have the same y. That's what this refers to. The y coordinates are the same. And so what is the related x coordinate? And that would be negative 4. Okay, now what about this? Let's solve for f of x, where f of x is greater than g of x. So in other words, again, we're looking for the x coordinate in inequality form, the x coordinates, that would show where this blue function is greater than the red. Okay, greater than, again, you got to think of these maybe in terms of y. The y coordinates for the blue are getting bigger as the x coordinates are getting smaller. You see that? The y coordinates for the blue are headed this way, the red headed this way, negative. And the y coordinates are getting larger than the y coordinates for the red as the x coordinates are getting smaller. So my answer here would be for x less than -4. The blue function is larger than the red for values of x that are getting smaller than -4. Okay, then a couple of word problems, and that will wrap up this particular lesson. This is an economics type problem for those of you who are headed into the business area. We have a quantity supplied function and a quantity demanded. So this principle of supply and demand for particular t-shirts at a concert. P is the price of a t-shirt. Okay, so find the equilibrium price, and that's another word for that is the break-even price. And the way we find that is just let this supply function equal the demand function. Okay, so to find equilibrium price, I'm just going to let the supply function equal the demand function and solve for P. Alright, so if I add 200 to both sides, I get 1200. And if I add 25 to both sides, I get 75. So now we're going to solve 75p equals 1200. And so our equilibrium price, or P, is $16. $16 represents kind of our break-even point. And now what is the equilibrium quantity? So to find the equilibrium quantity, we just replace P with 16 in either one of these functions, and that should be 600 t-shirts. So it's a two-part answer. $16 is our equilibrium price. The quantity, equilibrium quantity, is 600 t-shirts, just substituting 16 in for P in either one of these functions. Okay, that's the answer to part A. Determine the prices for which quantity demanded is greater than quantity supplied. Okay, so let's take our demand function, 1000 minus 25p, and let that be greater than the supply function, -200 plus 50p. Okay, and basically we're going to end up with that same answer. So price, we have 1200 is greater than 75p, or if you turn this around, we're going to get 1600 is 16 is greater than P, or P is less than $16. Okay, well, for prices, we can go ahead and get a little more specific. We know that this has to be somewhere between 0 and 16. Obviously, we wouldn't have a price below 0, so we could state the prices anywhere from nothing, which wouldn't make a whole lot of sense because we wouldn't give them away. Anywhere from 0 to 16 would be the price where quantity demanded is greater than quantity supplied. What do you think will eventually happen to the price of t-shirts if quantity demanded is greater? Well, the law of supply and demand says that if quantity demanded is greater than quantity supplied, that's going to drive the price up. So bottom line is prices will increase. So they've kind of created demand maybe by lower prices, and if the demand increases, then that will cause a increase in prices. Okay, last example. A company has just purchased a new computer for $3,000, and the company chooses to depreciate, this is an accounting term, depreciate the computer using the straight line method over 3 years. Depreciation is a way we devalue an asset over time. As an asset is used over time, then it's not worth as much as it was when it was first purchased. That probably makes sense. It's going to wear out. It's just going to be used up over time, and this particular computer, we're going to depreciate it, or we're going to show that it's being used up over a 3-year period. So the way we show how much that's happening per year is we take the original cost of $3,000 and we divide by the number of years that we want to depreciate the asset, and that's $1,000 per year. Okay, so we need to show that this particular computer is losing value as it's being used up. It's losing value at a rate of $1,000 per year. All right, so that's going to help us with letter A. Write a linear model that expresses the book value V of the computer as a function of its age. So the value as a function of its age, it will lower in value by $1,000 a year. So since it's decreasing in value, this really represents the slope of our line. And since it's decreasing, we're going to let that slope be a negative number. Okay, slope is negative 1,000. That's the rate of depreciation. And we're going to let the y-intercept will always be the initial value. It's kind of like the starting point of the value of the computer. So there's our letter A. What is the implied domain of the function? In other words, what are reasonable numbers to plug in for x? Well, the domain, which represents age, will be, it can't be less than 0, obviously. It could be brand new, or it could be up to 3 years old. That's all that we're going to depreciate it. So the implied domain is anywhere, any number between 0 and 3 inclusive. Now let's show the graph of this. All right, when you're graphing these functions that represent a real-life situation, it's very important that you label the axes. The x-axis, x represents a certain age, and the y-axis, or v of x axis, is going to be the book value in dollars, of course. Okay, so let's just plug in some numbers. Obviously, we said that the age cannot be a negative number. The range, or the domain, is going to be somewhere between 0 and 3. So let's just plug in 0. 0 means it hasn't depreciated at all, so its value should be $3,000. And let me just go ahead and set our y-axis. We'll do this in 500s. Okay, and we'll leave the x-axis in just normal units of 1. Okay, so at 0 age, which means it's brand new, it's still worth $3,000. All right, at 1 year, after 1 year old, it should be worth $2,000. 2 years old, x is 2, it should be valued at $1,000. And then when it's 3 years old, as far as its value, it's fully depreciated, so it's really not worth anything to us. It's probably ready to be replaced, and that's pretty typical for computers. Their life for a business is generally not more than 3 years, sometimes less. Okay, so there's the graph. And we've taken care of part C, and now we've got a couple more answers that we basically can just look at our graph and tell what is the book value of the computer after 2 years. After 2 years, since these are in 500s, our book value is $1,000. And when will the computer have a book value of $2,000? Okay, so here's $2,000 book value, and that's after 1 year. Okay, so I hope that's enough samples for you to be able to do the homework assignment and work really hard on that, and we will talk about this next time.